finalize our understanding of the absolute value, parent function, and transformations. So we know the absolute value looks like a V with a vertex normally at 0, 0, and points like 2, 2, negative 2, 2. On the Desmos video, some translations, some general transformations. So translations are transformations that shift the graph horizontally, vertically, but don't change the overall shape or orientation. So if you subtract h amount on the inside, the absolute value bars, it will move to the right h. And if you add k, it will move up k. So your vertex of your absolute value will always be, that's here, the new vertex is the hk. It's translated h horizontal units and y vertical units. Be careful with that minus sign in the equation there. So what about when you multiply stretches and compressions? So the graph of y equals a constant times the absolute value of x is the graph of that vertically stretched or compressed depending on how that value of a is. So let's just think of the positive version of a. That's why I put absolute value bars, because the negatives will do something else. But depending on a, it will be vertically stretched if a is greater than 1. So if the number out here is bigger than 1, so this is the formal definition, it's going to stretch, and if it's less than 1, it will compress. And this is a really good point, that the value of a acts like a slope. Like I say. So this is all your transformations all together. So it could be this complicated. You could have a stretch, you could have a move to the right h or left h. If that was a plus, it's going to move to the left. And then up or down k. If it's a plus, it'll move up. So let's see. Right, that negative's a reflection across the x-axis. That value is a vertical stretch if it's bigger than 1, or vertical compression if it's between 0 and 1. That's a horizontal translation, however many units of h. And that's a vertical translation. Multiple transformations at the same time. In general, to graph these, it's helpful to identify. You want to plot the vertex. Use a to plot the slope and connect the dots in a V shape. And if a is positive, it'll be facing up. If a is negative, it'll be facing down. Here's an example to graph. If we're going to graph y equals x minus 2 plus 3, I know that the vertex is now at positive 2. Okay, so for this one, the